Welcome back. We have a question here that reads, a body of mass 8 kilograms rests on a rough horizontal surface. The coefficient of friction between the body and the surface is 0.3. What is the force applied to the body in the position of limiting equilibrium to pull it at an angle of 30 degrees to the horizontal? So this is the diagram that the question is referring to. We have an 8 kilogram mass that is resting on a rough horizontal surface. The coefficient of friction between the body and the surface, mu, is equal to 0.3. We have an applied force that is acting at an angle of 30 degrees to the horizontal. So the question asks us to find the magnitude of this applied force. So what we have to understand is, if you have an applied force that is acting at an angle to the horizontal, we have to resolve that angle into horizontal and vertical component. Okay? The horizontal component of that applied force is what is actually going to move the object along the surface, and the vertical component of the applied force tends to reduce the normal reaction, and it is also the force that tends to lift the object from the surface. So moving on to the solution, if we should consider the applied force P and resolve it into horizontal and vertical component, let's try to draw a line first. Now we're going to have two important forces. The horizontal component is Px, the vertical component is Py. So if I should try to draw a triangle for that, we have the applied force P, we have the vertical component of the applied force as Py, and the horizontal component of the applied force as Px. And then we have the angle theta. So if we should use sine theta is equal to opposite all over hypotenuse, then sine theta will be Py all over the hypotenuse is P. Okay? So if I want to find Py will be P sine theta. Okay? To find the horizontal component of the applied force, we can use cos theta is equal to adjacent all over hypotenuse. So that will be cos theta is equal to the adjacent is Px all over the hypotenuse is P. Therefore, we'll have Px is equal to P cos theta. Okay? So if we go back to the diagram, this Px is P cos theta and the Py is P sine theta. What is the importance of that? So for this diagram, we'll have two vertical forces. We have the normal reaction and we have Py that are acting upwards, and we have a vertical force that is going to act downwards, which is the weight. So from Newton's third law, we will know that R plus Py is equal to the weight. So that is R is equal to the weight minus Py. What is weight? Weight is mass times gravity minus Py is P sine theta. So that is R. Okay? So it is important to know that for friction on a horizontal surface where the applied force is inclined, the normal reaction is mg minus p sine theta. So as you can see, because we have minus p sine theta, it means that the vertical component of the applied force actually reduces the normal reaction. We can now move on to analyze the question proper. It says that we find the applied force to the body in the position of limiting equilibrium. So this body is in limiting equilibrium. So whenever you have a friction problem, ask yourself, is the body in limiting equilibrium or in acceleration? Those two concepts are very important. When you know that, then you can be able to guide yourself into establishing the proper equation that you need to have. And if in the question no acceleration is given or mentioned, you are likely dealing with limiting equilibrium, okay? You can assume that the body is in limiting equilibrium. So going back to the diagram, we are in a state of limiting equilibrium. And in the state of limiting equilibrium, the horizontal component of the applied force must be equal to the frictional force. The state of limiting equilibrium is when the body is just about to start motion, okay? So the P cos theta component will be equal to the frictional force. It is important for us to start from there, okay? At limiting equilibrium, P cos theta is equal to the frictional force F. So that is going to be P cos theta is equal to mu r, because F is equal to mu r. So we'll say P cos theta is equal to mu into what is r? R is mg minus p sine theta, okay? Mg minus p sine theta. So we are going to have P cos theta is equal to, if I expand, I will have mu mg minus mu p sine theta. To collect like terms, I will have P cos theta plus mu p sine theta, because I want to find P, okay? So this is equal to mu mg. So to factorize P, we'll have P into cos theta plus mu sine theta is equal to mu mg. Now I can divide both sides by cos theta plus mu sine theta to be able to find P. So this will cancel this. Therefore, P is equal to mu mg all over cos theta plus mu sine theta. Now I can substitute the values. The coefficient of friction given in the question is 0.3. The mass of the object is 8 kilograms. Acceleration due to gravity is 10. Divided by the angle is going to be cos 30 plus the coefficient of friction is 0.3 sine 30. So 0.3 times 8 times 10 is 24 all over cos 30 is 0.8660 plus 0.3 sine 30 is 0.15. So this is going to be 24 all over 0.8660 plus 0.15 is 1.016. So 24 divided by 1.016 is 23.6 newtons. So that is the minimum applied force required to move the object or the body along the rough horizontal surface. And that answers the question. Thank you very much for watching this video. If the video is helpful to you, please like it, share it, and do not forget to subscribe to our channel.